Hello there, Mr. Sutton bringing you this lesson on slope fields. So for this one, we're going to be graphing slope fields and also matching a differential equation with its slope field, and finally graphing solution curves on a slope field. Let's talk about slope fields. To start off, let's define what a slope field is. We've seen this before, but the official definition, a slope field is a graph of the slope of an equation at each point. So in other words, a graph of all the tangent lines. So, for example, let's see if we can sketch the slope field for this differential equation using the points that they've indicated here on the graph. So to make this systematic and easy to do, I recommend you make a table of points and then plug the x and y values into the differential equation. Once you've got all the slopes kind of mapped out what they're going to be, then go ahead and draw each slope. So for this graph, we need x values -2, -1, 1, and 2, and the y values 1, 0, and -1. When I make my table, I usually make it so that it's laid out just like the grid over here so that I can directly transfer my slope to a drawing. So I start at -2 on the x's, go to +2, and I go from top to bottom with the y values here. So I'll do the first one, and then I'll pause the video and let you do the other parts of this table here. So for example, 1 and -2, this is the x value -2, the y value 1. If I do 1 over -2 in the differential equation, that's a slope of -1/2. All right, pause the video and see if you can fill out the rest of this table. All right, let's see how that went. So for this next one, we have a y value of 0 over x value of -2. So that's 0 over -2 is 0. And then we have -1 over -2, which is +1/2. Next, we're going to have 1 over -1, which is -1. And then 0 over -1, which is 0. In fact, this whole row is going to be 0. Down here we have -1 over -1, so +1. Next, we have, let's see here, this is going to be 1 on the bottom of all our fractions now. So 1 over 1 is 1, this is 0, -1 over 1 is -1. And finally, we have 2 in the denominator for the rest of these. So we have 1/2, 0, and -1/2. And you might have noticed there's a little bit of a pattern in this table. Certainly once you pick up on patterns, you can fill out these tables a little faster. All right, we're going to go through now and draw all these slopes. So at, let's see here, -2, 1, that's right up here. We've got a slope of -1/2. So I'm going to draw a line, a little slope line right here that has a slope of -1/2. Now, if you're not sure what that looks like, I usually like to kind of extend it so that I can kind of get a picture of what the slope is going to be and then just draw a little piece of that. So like this. And then down here at the x-axis, we've got a slope of 0 down there, so I'll draw a horizontal line, and then a +1/2 here. So pause the video and see if you can draw the rest of the tangent lines here. For this one now, we've got -1, and then we have 0, +1, and there's nothing down here because on the y-axis you have an x value of 0, so that's going to be undefined. Back over here we have a slope of 1, 0, and -1, and this is going to be symmetrical to this first row here, this first column. So we have 1/2, 0, and -1/2. Here's another example. Given this differential equation, pause the video and see if you can sketch the slope field given these values. All right, so I'm going to make a table just like before, going from -1 to 1 on x values, and the same thing actually on the y values. So if I have, let's see, this is x is -1 plus the y value 1, that's 0. And then we have -1 plus 0 is -1. -1 plus -1 is -2. Up here, I've got 0 plus 1, and then 0 plus 0, 0 plus -1. And finally, we've got 1 plus 1, 1 plus 0, and finally 1 plus -1 gives us 0. Putting those slopes in there, we've got, let's see, 0, flat line, this is -1. -2 is going to be steeper, and then over here we have 1, 0, and -1, and finally we have 2 is pretty steep compared to these others, and then 1, and flat line 0. For this problem, we're given a slope field and asked which of the following could be a differential equation represented by this. So this is really just kind of a process of elimination game. It's kind of fun. I usually just test points from the slope field and eliminate the equations that don't give me the same slope when I plug in the x and y value. So for example, looking here at 0, 0, because that's an easy point to test, the slope at 0, 0, based off the graph, ought to be 0. It's a horizontal line right there. Let me go through my answer choices and plug in 0 and 0 for x and y, see which ones actually do give me 0. Choice A, 0 minus 0, that's 0. Choice B, also 0 minus 0 is 0. But now choice C and D, in both of these, you're doing 0 divided by 0. So C and D are not going to work. And then E, 0 plus 0 works. So we can at least eliminate choices C and D because those were undefined when we tried plugging this point in. All right, pause the video and pick another point on here and try to eliminate some more answer choices. All right, so for my point, I picked 1, 2. So at 1, 2, I have a slope of -1 right here, or at least it's negative, not that negative. And now testing that in my answer choices, choice A, this is going to be 1 minus 2, which is -1, so A is still in the running. Choice B, this is 2 minus 1. That's +1, so B I can eliminate. Choice E, I got 1 plus 2, which is 3. Also not going to be in the running anymore. So we've eliminated B and E. A is all that's left, so we have to choose it. Here's another one of these matching questions for you to try out. Pause the video and give it a shot. All right, so I notice here that at 0, 0, which is like my favorite point to test, that we have nothing for the slope. It's not defined. So since I have D and E at 0, 0, let me see which of these also gives me D and E when I plug in 0 and 0. Choices A and B give me undefined, so those are still in the running. But choices C, D, and E, those all give me 0, which is not undefined. So I've eliminated 3 answer choices with 1 test here. It's sometimes possible to eliminate all 4 wrong answer choices if you pick the right point, but that's kind of tricky. So I'm going to test out another point now. I'm going to test out 0, 1, which has a slope up here of 0. And I'm picking 0, 1. I'm picking a point that only has 1 0 in it because I see my 2 answer choices involve division, so it's going to matter which order I divide things in. So testing out choice A, this would be, let's see, 1 divided by 0, which is still undefined. Choice B is going to be 0 over 1, which is 0. So I can eliminate choice A because that's undefined, and I wanted 0 this time around for my slope. So since it's not A, it's got to be B, and we move on. For this next problem type, we're asked to sketch a solution curve with an initial condition of 1, 4. So recall that a slope field by itself is just a graph of all the possible functions that have a given slope, not just a specific one. However, we can pin down the exact function if we have a point. So if they give you a point, all you have to do is, starting at that point, draw a curve that follows the tangent lines. So for example, if we have the point 1, 4 like they've given us here, we're going to start up here at 1, 4, and then we're just going to follow these tangent lines until we get from that point to the other end of the graph. So follow the tangent lines just as best you can and call it a day. We're going to do one more of these problem types. New slope field. This time you have an initial condition of 3, 4. Pause the video and see if you can draw that curve. All right, so at 3, 4, that's right here. So this tangent line's our launching off point. We are going to follow that tangent line as far as we can and get to the other side. So that's it for slope fields. Till next time, this is Mr. Sutton signing off.